Welcome everyone! We are here today for a quick tutorial about how to implement ShipCore in our project. As you can see, we already have ShipCore Lite installed in our project, and the main thing we want to do is to create our ship, the first one. So let me move to Blueprint. We're going to create a new one. Blueprint class will be Pawn, PP, player Pawn, testing ship. And I'm gonna open it. There we go. Okay, I want to add a new mesh. It can either be skeletal or a static mesh. I'm gonna start with static. I'm gonna call it ship. It doesn't really matter the name you give it. And I'm gonna assign to it a mesh. I'll be using the mesh I already created, which is this one here. And we need to check a couple of things. So let's start with the physics. So physics must be enabled. And the other thing is about collisions. We need to ensure that both our ship has collisions. So we can see as show simple collision. So it has to be a collision on it. And we need to have a collision enabled. So it can be block roll, can be dynamic, whatever you want. You just need to have collisions enabled. So that's the main step. So now, extremely important guys, we need to replace the root of our actor. So I dragged my ship onto the root to replace it. So now the ship is the root of our actor. This is extremely important, otherwise other stuff will not work. So let's start adding our components. Will be thruster, the first one we add. So we have two choices. So this one here is the C++ version of the component. This one up here is the Blueprint one, which inherits from the thruster manager component. Now I will be adding the gyro manager component. Same thing here, C++, Blueprint inheriting from this one. And there we go. So now we have our ship. We have our two components. This one is needed, the thruster is needed for linear movement, so up and down, left and right, front and back, and the gyro to rotate around. All right? Okay, we can do a little test. So if now we have the tick, we get our thruster into like that set thruster input. We can set it to 1 on the X. It will be accelerating forward. So let me add the ship like this, and I'm gonna do a quick simulate, and there she is. Nice. Okay, so now we know that this is working. What I'll be doing now is to go steal from my blueprint all the settings and inputs, so we don't take up too much time. So demo, I went into ShipCore, blueprint, demo. Now we have our ships here. I'm gonna go into the spaceship base, and I wanna grab the tick, except this one. I wanna the thrust input, all these come to me. Inertial dampers. Reset camera zoom. We have the reset camera. I'm gonna steal all this stuff. I feel naughty today. So this one is the most important, otherwise nothing will work without about input. So this one will say in the moment that the controller receives the ship receives the controller, we add the mapping context so we can receive inputs. So copying, moving back to our ship, and pasting everything. There we go. Let me set up everything up, and here we are. Okay, so now we need to create our variables. So it will be right click, create variable, right click, right click, right click. Should be all, yes. So if we now compile, we are going to receive a bunch of warnings and errors. So now our blueprint, which is saying, hey, I cannot find this thruster manager component, because in this case we are using another version of it. So there we go. compile, this one is fine. So now we can move here. So in this case, this one wants spring arm, and obviously we need the camera to be able to move it around. So I'm gonna add, click on ship, clicking on our spring arm. There we go. And I'm gonna add a camera to it. Cam, there we go. So let me just disable the collision test, extend a bit the arm. I also want to rotate it a bit, maybe like this, rotate the camera. Okay. So we see this logo here because we still have errors inside our code. So let's move here and let's check what is whinging. So this one again, thruster, I'm gonna drag and drop on the side. That's for the gyro, again, gyro, drag, drop. And this one is for manual input enabled. I'm gonna enable it by default, compile and save. Nice. Okay, so now we don't have errors anymore. In the viewport, the ship is here. No one is crying anymore. And if we move back to our scene and we set the auto process player 0, so now we're gonna, when we press play, we are gonna be using this ship. So select viewport, play, and as you can see now I can move around the ship. So you wonder why there are no thrusters around, why there are no effects. There are no effects because in my demo ship I added tons of visualization and fake thrusters around. As you can see, this is a simple plane. I'm gonna open it for you. This is a simple plane with a UV made in a specific way that allows me to offset it via shader. So if you want to see how all this stuff works, you can go in construction script. There will be a bunch of code and scripts to set up our materials for the various thrusters. And the management of those is inside the tick, inside animate cosmetic thrusters. So in this case, what we're doing here, we are getting our thruster manager component and accessing to the normalized thruster strengths. Every one of those is a different X, all right? So with this, you can define the strengths of the various thrusters and offset them, or you can even use a particle system. It doesn't really matter. So this one is the variable you want to use in case you need to have some effect, as example. So this will be the output of our thrusters. It's gonna tell you from 0 to 1 how much that thruster is pushing. All right, so we can move back to our testing ship. We can move back here, and I'm gonna show you how we handle this kind of stuff. So as you can see, we have all these input. We have the thrust input, we have the lift, so up and down, we have the steer, the roll, and we have our inertial dampener. So what the inertial dampener does is to enable or disable the inertial dampeners. And what they do is to keep your ship stable and in place. So if your inertial dampeners are active, the ship will try to stop itself. As you can see here, look at the visualizer at the bottom right corner of the screen. If I move to the side and lift my finger, the opposite thruster will try to stop the ship. Same is for every other thruster. So you can see the visualizer there. As I'm traveling around, they are pushing and trying to keep my ship steady and not drift around. So if I let my fingers go, as you can see the speed on the bottom left corner, I let the key, the opposite is thrusting, is pushing to stop, and the ship will now stop. Okay, so if I want to disable the inertial dampener, all I can do is just press Z. I'm gonna disable it. As you can see on the bottom right, it just got enabled, disabled, enabled, disabled. So if I now push a bit, as you can see, the ship is now moving at 1,683 units per second. And it doesn't matter the direction I'm looking, I will keep traveling in that direction. So for instance, I'm looking at our platform, and I will keep moving and drifting into space. If I enable them, the ship will stop. Okay. A couple of other things we can check are our dispatchers. So if we move to our testing ship, we can have a dispatcher for the thruster. Sorry, So if you click on the thruster manager component and you scroll down on the detail panel, you can see we have a dispatcher for the on inertial dampening changed. And the other one is the speed limiter active changed. So now we have an event which will get fired in case we enable or disable these features. And these dispatchers can be read from other places too, as far as we have a reference to this actor. So what we can do is to go to our widgets. We have a couple of here. We have the thruster visualizer, we have the inertial dampener. So if we check the inertial dampener as an example, what we're doing here is we check if the pwner has the thruster manager. If it has it, we bind an event on inertial dampening changed. And when this is fired, we just set the dampener UI state, as you can see here. So when our ship is changing those values, the UI will reflect what is going on. And that's it for this quick tutorial about the light version. So with this, you should be now able to set up your own ship. If you have any question, just hop on Discord and I'll be super happy to help you. Alright, let's move to ShipCore Pro. So as you can see, we have ShipCore Pro installed and we are now moving. Let me close the tab. Now, what we want to add first is our Autopilot Manager component. So as before, the Autopilot Manager component is the C++ while the AC Autopilot Manager component is the blueprint version that inherits from this other one. You can find these components in our plugins, ShipCore Pro, blueprints, and here they are. So here there are a bunch of other elements, like our Autopilot Spline Path, our landing pad, and well, camera shake, and we have our tool we used before. So again, let's stick to the Autopilot, then we see the rest. The Autopilot Manager component has a long list of parameters, and it is divided in different phases. So we have the auto phase, which allows the ship to slow down, to accelerate, and stay within a max and minimum speed. And we'll try to maintain the course along the path we will be drawing. The docking activation distance allows us to make so that the ship within this distance, so as soon as it reaches this distance from the end, turns into docking mode automatically. Alright, so we have the auto, we have the docking, which is obviously the docking phase. We have a lot of options, and each one of those has the description when it's hovered. So you can change stuff and do a bit of tests. We can run through a couple of them. So, well, max docking speed, minimum docking speed. We have this super interesting one, which is the brake with stronger thrusters. So let's say that our thrusters are uneven. So in this case, we have this thruster, which is 31 million. And let's say we want this thruster here to be 40. So now we know that the ship has the stronger thruster in the back, all right? So for the forward direction. So in this case, what we want to do with this option is to have the ship flipping itself to use the rear one when the docking speed exceeds this specified one. So let's say that we are coming in really hot and we are traveling at 10,000 units per second. So in this case, we are exceeding 5,000. The ship will flip itself to use the stronger thruster until it will reach 5,000. So under that, we'll just align to the landing pad and do the landing. Then we have our flight phase. The flight phase will use the speed specified at the point, which we'll see in a second. While the precise phase is the one that we can use to do really precise maneuvers. So let's move to our spline. I'm gonna put it in the map, if Unreal allows me. There we go. Let me do some splining around. I'm gonna move back a bit. I'm gonna pull these. As you can see, there are all the points data on display, and we can start dragging around. Let me go a bit further like this. We can move this one here, here, here. Maybe we can do a little loop, and then the landing. So let's say that I want to land on our actor here. So this one is a really common actor. I just have a mesh and a collision around, which is overlappable. So let's click again on our spline, our Autopilot Spline Path. If we go down here, we can define the landing pad actor. So we can select like a landing pad, can be whatever actor, and then set landing pad actor. So now the spline automatically set docking for the point before the final one, and will be idle on the final one. Let me move it a bit back like this. I don't know the speed the ship will be in this point, but we should try. So what's going on here? Here we have a bunch of turns. Everything is on auto. The ship will reach docking point, will enter docking mode, and then land on the last point. So let me add the ship here. Have our test ship. There we go. What we need to do here is to set, let me expand this, go to the Autopilot Manager component, and we can set here at the top the active Autopilot path. Bam. So now we should see, pressing simulate, the ship moving and doing her own things. So now the ship is slowing down a bit to approach its turn, twisting a bit. And the drift here is given by the strength of our thrusters and the minimum and maximum speed. So other values, if you go in our Autopilot Manager component, are for the auto phase, the curvature sensitivity. So this curvature sensitivity makes so that the ship is more lenient. So the higher is the curvature sensitivity, the more the ship will slow down when approaching curves. Now the ship will get into docking mode, braking, aligning, and landing. There we go. Stopping. Okay, so let's change some value. So let's say that we want this point to be precise. So as you can see, even the spline becomes like super straight. And if I now start our ship again, let me click here so we can see. Ship is moving like this. We'll reach the precise point, and now it kicks in. Ship aligns, moves to the other point. And then the ship starts back on her path. So what else we can test here? We should test something like... So selecting this point, we can set the flight mode, and we can define the speed we want the ship to reach as maximum speed. Let's say we want to go at a maximum of 20,000 units, and maybe firing up an action tag like show message 01. Then you can obviously link whatever you want to these kind of dispatchers. Okay, so now we have our action tag set. What we need is to add to our testing ship our dispatcher, otherwise we cannot receive the message. So now we can see all the dispatchers here. We can go for the on spline point action tag passed. Here we will receive the action tag we described and the index of the point we just passed. So let's say we just for now print string. Obviously you can link these to whatever you want. It can be a data asset based on these. You can have messages, you can search in the data table, whatever you like. So for now we're just passing these. Will be in a bright red, and for 10 seconds. 10. So now, let me save. We can move back to... Oh, let me actually move the ship so we don't have to wait the whole turn. There we go. Now the ship will pass this point, which is the flight one, and we'll start to speed up. Now we have the show message 01 up here, which is our tag. The ship obviously will be overshooting the target over a lot because it was too fast, because the auto mode is not anymore in place. And then it will land. Okay, so we can have a couple of tools to debug and see what's going on. I'm going to show you if we open our Autopilot Manager, we can, as example, enable the debug print. I'm pressing play. So now we can see a couple of points. We have the yellow one, which is the current position on the spline. We have our rotation one, and we have our blue one, which now disappeared because we are not anymore into the auto phase. The blue one is the one that defines the speed. So there are a bunch of calculations, and based on the angles and position and distance and speed of the ship and everything compared to these points, the ship will define the actual speed. So as you can see now, we are in docking mode, and she will be docking as we saw before. So let me move to another map. So in this mode, we can actually, let me zoom back in, give, as you saw in the video, a bunch of disturbances to the ship. Let's say that the ship got hit by a rocket, we hit something, or there was an explosion. I keep like disturbing the ship now. Stop. But as you can see, the ship keeps trying to keep the course, no matter the orientation. Then we'll be reaching this point, we'll be enter docking mode. You see it's like braking with the strongest one in the rear, and then landing. Oh, sorry ship. Okay guys, so I can show you another level, and let me start with the ship. So here we have the ship. As you can see, we have all our buttons here, and you can see there is an auto docking button, which is on the G key. So as you can see now, I have this visualizer, which is showing me the target landing pad. So I have a little script that is searching for those based on the angle. If I turn away, it will fade away. So let's say I want to land on this free one. Okay, I just press G, the ship enters autopilot mode, and will start to land on the point. Alright, giving back to me the control. So again, like in any other case, if I go really fast, let me do a bit of speed up, and then I will press G to land. The ship will turn, brake as hard as she can, and then getting ready to land back on. So all this is happening because in our Autopilot Manager component, in the docking section, we have our brake with stronger thruster. Otherwise, the ship will just align and try to brake with whatever has available in that specific direction. So something else I'd like to tell you is that the Autopilot Manager component does nothing else than using the same inputs you have for the gyro and the thruster. So as you can see in our tick, we are using the set thruster input, set gyro input, and the Autopilot Manager is doing nothing else than this. It will just be way faster at doing calculation than us, but yeah, that's it. So another thing I can show you is with the button V, you can enter inside the cockpit, you can have a stroll around like this, and even from here, as we said before, we can just press G and do the automatic landing. So camera can be moved with Alt. When you are outside the Alt, we can allows us to orbit around and zoom in and out with the wheel. Oh, it's super dark because of this huge ship there. And Alt will reset the camera. Oh, ship is landing. Alright, something else we can check is the multiplayer part of Replication. So we can just go here, set number of players to net mode, either listen server or client, it doesn't really matter in this case, and we press play. So the other ship just landed. Let me move the other window here. So as you can see, everything is already replicated. Someone is about to land on our head. Whoop. There we go. Even maneuvers like the autopilot, even autopilot and everything is working in multiplayer. So thank you guys for watching. Drop a like and a follow if you can, it always helps with the algorithm. If you need support, you want to request a feature, or you just want to help for your own project, come in my Discord. I often do live streams on my community server and help whoever I can. I hope this tutorial has been helpful, and see you next time. Bye.